Royal Australian Navy approached us to redesign their munition lockers located on board their naval warships. Magazine lockers ensure the safe storage and transportation of munitions by protecting against things like temperature fluctuations, impacts and shocks, as well as unauthorised access. Current magazine lockers are still designed on standards that date back to the 1970s. The Royal Australian Navy wants to bring their lockers into the 21st century for both safety and protection purposes.
We are focusing on innovative and emerging material solutions and looking at creating a bulletproof locker for combat purposes. The design will also defend against environmental hazards that have the potential to cause sudden internal detonation of the locker's sensitive contents. These new design innovations will revolutionise the current state of the locker, bringing together technology, ingenuity and modernisation.
The first step was to define what the locker needed to do. We started this process by looking into past iterations of the design, as well as identifying the hazards that we had to deal with. Previous locker designs were found to be either stainless steel or aluminium, in a rather generic shape, a box. In addition to this, they lack storage flexibility, being capable of only storing one type of ammunition. This opens the door for a new and improved design, which is capable of being altered to store more than one type of ammunition, which means you only need to buy one type of locker to store everything you want.
The primary hazard lockers have to defend against is enemy fire. Current designs cannot withstand 50 caliber rounds. .50 caliber gunfire is the main focus of bolster protection. However, our design will also be able to mitigate damage from rockets and explosives.
However, magazine lockers are currently failing due to storage and environmental conditions as opposed to combat. Operating at sea brings with it increased corrosion rates, temperature and dynamic load. The marine environment exposes the lockers to corrosive attack, and they have been found to fail under a variety of corrosive media. This is another flaw that needs to be addressed via a range of exotic materials and anti-corrosion technology. NATO standards indicate that these lockers can be exposed of temperatures up to 63 degrees Celsius. The Navy requires the contents of these lockers to be stored below 38 degrees. Current solutions are to douse the locker in water to cool it down. We are currently looking into a solution that is less primitive, such as water jackets or refrigeration. Finally, naval ships being at sea cause the locker to be in a constant state of dynamic loading. This will cause failure via fatigue if not designed for.
From this initial analysis, we created our assumptions and key performance metrics. The main assumptions for the project were: the maximum temperature the locker will be exposed to will be 63 degrees centigrade. The locker will be exposed to inertial loads of 2G in the vertical plane and 1G in the horizontal. The locker will be constantly exposed to a harsh corrosive environment. The following performance metrics will be used to track the progress throughout the project. The design must be scalable and compliant to NATO standards. The design must withstand the force of a 50 caliber bullet. The contents must be kept below 38 degrees centigrade. The design must be dynamically stable and designed to operate effectively in a marine environment. The design must isolate shells from one another in an effort to reduce the potential chain reaction given a random detonation. Upon reaching all of these KPIs, we will approach the Royal Australian Navy in an effort to gain funding to create a prototype locker, which we will then destructively test to critically analyse our design.
As team leader, my primary responsibilities involve project management and the coordination of team meetings. With respect to the technical design, I'm involved in the evaluation of design using structural FEA, impact and plastic modelling, and multi-physics analysis.
Throughout this project, I will be in charge of material selection of the locker with respect to the environment and ballistics it has to defend against. With regards to the team, I am the shaper, instilling focus and direction in my fellow team members.
Moving forward into the project, I will be involved in key decision-making processes in the design, focusing on manufacturability, functionality and the ergonomics of the magazine locker. I am also the key contact between the client and the group.
In UQ Defense Solutions, I'll be in charge of finding the damage and penetration from enemy gunfire, as well as ballistic figures of merit and current armor plates. My main team role is stakeholder management and client relations.
My role in the project is mainly based around graphical design of the locker and lead editor of video presentations. My part on the team is the secretary, and it involves writing minutes in meetings and handling team logistics.